All right, so this is a problem that in reality seems simple because it has a free end here, but unfortunately this is unknown, this force FBD that we are seeing acting here along the biceps. And because we don't know that, then we end up, if we tackle using a cross section right here to point E, as the problem is asking to find internal reactions resultant in the point E, then we end up with four unknowns, and we can write only three equations. So evidently, we cannot solve straight going to this, making a cross section here at point E, and use the idea that we have a free end there. So we have to find the FBD. And for that, we separate the forearm. As we can see, I still had it here because it was easy for me to draw that. But basically, we look into this separation here in this joint, elbow joint. And we can see this as the problem is saying it as a pin joint, pin support right there. So in that case, we are trying to find FBD. This is all we need. We can, have CX and CY there. I put them there, but we are not interested in that because once I do figure out FBD, then we can take the right side of this point E and solve for EX, EY, and the moment at E. So very simple again after we consider this first step to isolate, make an overall free body diagram and isolate this joint, elbow joint. Then we can write the moment. This is we interested in only in FBD. We can write only one equation, 7 moments about point C, and we figure out FBD, which we are doing it here. And here it's again, we can see that this FBD is having an angle of 75, is not exactly perpendicular on the forearm right here. So has an angle for this case with 75 degrees. Of course, this angle in real life is changing, but only for the sake of the simplicity and for this problem, we consider it that way. So we can see that the one component that goes, if we decompose this in two components, FBDX and FBDY, only the FBDY will give moment about point C. The other one, FBDX, goes through that point C, and it will not give any moment in this situation, of course, for this angle. So uh, basically, we write the component. The Y component will be, as you can see. Again, I will make another video about trigs and components because I think sometimes we might need to work and refresh our memory on that. So I'll put the link on this video down there in the comments of the video. So here is, as you can see, we write the sum of moments about that point E. That will be positive because that vertical component, the way we put it here, it's going to rotate this forearm in the counterclockwise direction, exactly as we are selecting as the positive there. So sine is just the opposite of these angles, the opposite leg here. So that would be the sine component. Will be the Y component will be FBD sine 75, and then the moment arm is just this one, which is 70 millimeters, and if we put it in meters, that's going to be that way, 0.07. And then we have the weight of the ball right here, t kilograms times the gravitational acceleration, 9.81, plus the moment, the arm, which is this exactly all the way from here to there, 0.3 meters. Easy, we solve for it, we get that value, and then once we are done with it, then we could have take the left side of this whole thing, but in that case we need to solve for CX and CY, and I feel that we have two more equations to write as opposed to take only the right side, and we have less equations to solve, to go through. It's faster. So in this case, we redraw free body diagram here. Once we know the FBD, then we have these three components, and this time there is no pin connections. Point E is not a joint, it's just through the bone. So it's the left of E and the right of E is just a fixed connection between the left and right. So that is, we have three components: EX, EY, and the moment, like we previously discussed. And again, we use Newton's second law. We write sum of forces on x direction. This time is this component, which is of the FBD. It's going to be FBD on x cosine, because this is the component right there. Again, I'll explain that if you have hard time understanding cosine and sine in another video. So then we go on, after we solve for it, one unknown, one equation, solve for it, and then we go for Fy, sum of forces on y direction, and we find Ey. As you can see, Ey is positive the way you selected. Then this was also going positive direction, the y component of the FBD, and the y component, this mg is only acting on y. So we can see that easily we can have, and the way I selected Ey going upwards, I get a negative sign upwards, which means if I want to put it positive, then I have to turn the vector going downward. Same idea, sum of moments about point E, and the way I selected clockwise, I mean here, that's going to be negative with that sign that I selected here as positive. Then again, only the y component will give a moment here. The x component goes to E, and it doesn't give any moment, so that's my y component of FBD. The moment arm in this case is just 35 millimeters, and then mg basically is also giving a component, and we have 230 millimeters plus 35, it would be 265 millimeters. And when we do this, we get this result. I hope this it's showing a very simple way to solve a little bit more complicated than a simple problem with the free end, where we know all the external loads. In this case, we didn't know the external load. Hope you have a beautiful day, and let me know if you have questions.